All right, guys, we are getting ready for our Chapter 5 test, and hopefully the review video, this isn't the first time you've looked at the review. I don't want you going through the review problem by problem with the video. You should be trying to do these problems the best that you can on your own, and then turning back to the video when you get stuck and you can't figure out what to do. So a lot of this is things that we've been doing for a while. So these first couple of problems, it's nothing, a lot of it's not even from this chapter. So for example, number 1, differentiate with respect to x, y equals e to the 5 minus 2 over x. So if I rewrite that, y equals e to the 5 minus 2 over x. Well, y prime, if this was e to the u, it would just be e to the u, so my 5 minus 2 over x. But we also have to multiply by the derivative of the inside. Okay, this is just the chain rule. So the derivative of the inside, that 5 minus 2 over x, can be rewritten as 5 minus 2 times x to the negative 1. So when you take the derivative of that part, the inside, you end up with positive 2 times x to the negative 2, or 2 over x squared. So when I do my chain rule, I got my e to the 5 minus 2 over x, but I've got to multiply by the 2 over x squared. And I'm going to rewrite that. Let's put the 2 in front, e to the 5 minus 2 over x, all over x squared would be my final answer. All right. Okay, number 2, again, an older problem, something that we've been doing for a while now. I'm looking for dy dx if y e to the x minus x is equal to y squared. So when I take the derivative of y is y prime, and we're doing the chain rule here. So I'm doing the chain rule of y e to the x. So y prime times e to the x, where'd my pencil go? Plus the derivative of e to the x is just e to the x, but then I have to times by the y. So I get another y e to the x. The derivative of minus x is just minus 1. The derivative of y squared is going to be 2y, but then my chain rule tells me I've got to multiply by y prime. Now we are trying to get y prime by itself. So let's see, we got to get the y primes together. So I'm going to take this and move it over. So I end up with y e to the x minus 1 is equal to 2y times y prime minus y prime e to the x. So when I factor out the right-hand side, I end up with y prime multiplied by 2y minus e to the x. And on the left-hand side, I still have y e to the x minus 1. So to get y prime alone, I'm going to divide by that parenthesis right there. So y prime will equal y e to the x minus 1 divided by that whole parenthesis, 2y minus e to the x. And that's going to be my final answer. Now, if you were doing the multiple choice test, be careful, because keep in mind that I moved my y prime e to the x to the right-hand side. They could have moved this to the left-hand side and then taken this part and moved it over. So your answer could have been, basically the top and the bottom are getting multiplied by negative 1. So this could have been 1 minus y e to the x. And on bottom, you would have had a positive e to the x minus a 2y. Those are equivalent answers. As long as you can recognize that, you'll be okay on the multiple choice. Okay, number 3, differentiate y equals x cubed minus 2x. Actually, x raised to the 3 minus 2x. We should be careful how we say that. We don't have any special rules when I'm dealing with an x down here and an x up there. So we're going to natural log both sides so that I end up with x to the 3 minus 2x. Because with the natural log, remember, I can take this exponent and bring it down in front. So I can get natural log of y equals 3 minus 2x natural log of x. So now I don't have an x up in my exponent and another one down in the base. Everything's down in the base. So when I take the derivative, and I need to be careful because I'm quickly going to run out of room here. The derivative of the left-hand side, the derivative of natural log of y, is going to be 1 over y prime, and that's going to equal the derivative of the right-hand side. We've got a product rule. So I take the derivative of the first, which is just -2, and I multiply that by the second, which is natural log x, and then I'm going to add the derivative of the second, which is just 1 over x, times the first, which is 3 minus 2x. So when I rewrite this, can we combine a couple steps at once? Let's not. Let's just do y prime over y equals -2 natural log x plus 3 minus 2x on top and x on the bottom. Okay, we are looking for y prime. We're not looking for y prime divided by y. So I'm going to multiply the y over to the other side. So I end up with y prime equals -2 natural log x plus 3 minus 2x over x. I'm putting that in parentheses because I need to multiply that whole thing by y. And I know what y is. It's clear back here at the beginning of the problem. It told me what y was. Y comes from the very beginning. So y is x raised to the 3 minus 2x. So my final answer is going to be y prime equals -2 natural log x plus 3 minus 2x all over x. And instead of a y, I've got to put my x raised to the 3 minus 2x. So that is going to be your final answer. And I don't imagine they would try to simplify it any further than that. I don't think they're going to distribute that x to the 3 minus, like if this was multiple choice, they're not going to distribute that x to the 3 minus 2x because that's just going to make the problem messy. And I don't even know if this inside the 3 minus 2x over x, they might split that up to be like 3, where did my pen go? They might split that part up to be 3 over x minus 2, since 2x over x is just 2. But again, as long as you can recognize that those are all the same answer, just in different forms, then you should be okay. All right, number 4, this is a great big one. So we are going to run all out of all kinds of room. So what I'm going to actually do, number 4, just in case you're jumping into the video at this point, we're going to move number 4 to the end of the page. So let's scroll all the way down. I know if you're watching, it may not matter, but we are going to, hey, add a page for me, would you? Not there. How do I add a page? You guys love learning with me. Let's add one more. Come on. There we go. Add a page. Thank you very much. We're all learning things together. Okay, so this is number 4. We're just moving it to the very end so we have a little bit more room to work. It wants me to solve x y prime equals y. So what that means is my final answer needs to look something like y equals something, okay? I want a y equals at the end of my answer. So first thing I'm going to do, y prime can be written as dy dx. So I can rewrite this whole thing as x dy dx equals y, because I'm trying to get my x's and y's on the same side. My x is on one side, my y is on one side. So I'm going to move the, let's see. Let's just move the dy over. So this can be rewritten as x over dx equal to y over dy. Are we okay with that? No, we're not okay with that. We don't want those on the bottom. So let's go the other way around. We want to move the y over here to the left. So we get 1 over y dy. And then we're going to move the x over dx all the way over. So it's going to become 1 over x dx. So we just separated our variables. And that's going to make it a lot easier because now when I integrate, my dy's are on top, they're not on the bottom. Makes our life a lot easier. So when I integrate both sides, we are going to end up with, the nice thing, 1 over y dy just becomes the natural log of the absolute value of y. And 1 over x dx becomes the natural log of x plus c, absolute value of x plus c. Now from here, we've been doing these for a while now. We're going to raise both sides to the e. So I end up with e natural log of y. So the e and the natural log cancel out. So I get absolute value of y is going to equal e to the natural log x plus c. Remember this part right here, and we've done this quite a few times. We can rewrite that as e to the natural log x times e to the c. And what I like about that is e to the c is just some big constant. And e to the natural log of the absolute value of x is just absolute value of x. All right, so when we clean this up a little bit, I know that my y is going to be positive because natural log of y, we've got to have a positive value there. And then my x, it doesn't matter if it's positive or negative. It's getting timesed by some constant that might be positive or negative. So we can just say c times x. So y is going to equal cx. That problem was a lot cleaner than I thought it was going to be. So good thing we moved all the way to the end for that great big giant problem, huh? Okay, number 5. We'll switch colors here a little bit. If the graph of y equals f of x contains the point 0, 8, so there is an initial condition right there, dy dx equals negative x over y e to the x, y e raised to the x squared, and f of x is greater than 0 for all of x, then what is f of x? All right, so let's clean this up a little bit. Again, I want to separate my variables. So this y I'm going to move over, and the dx I'm going to move over. So we're going to get 1 over y dy is equal to, I've got negative x over e to the x squared dx. So I got my x's on one side, I've got my y's on the other side. And do we care about that e to the x? Probably. Let's rewrite this one more time. 1 over y dy equals negative x e to the negative x squared dx. Now we're going to integrate both sides. That does not look like an integration sign. We're going to integrate both sides. In order to do that, though, my left-hand side, that's going to be easy. But my right-hand side, negative x times e to the negative x squared, let's try a u substitution. So let's let u equal negative x squared. So that means that du, I think this is going to work because du will become negative 2x dx. And if I look back at my problem, I don't have a negative 2, but I have a negative x. So I want to move that 2 over. So I can rewrite this as, where did my pen go? 1/2 du equals negative x dx. And it looks like that's going to clean up that variable for me. So on the left-hand side, I still have the integral of 1 over y dy. But that's going to equal, I'm going to plug in my u substitution. So 1/2 integral, instead of the negative x, that goes away. And I get e to the u, and I get du. So that's cleaned up a whole bunch. So when I integrate both sides, my left-hand side becomes, what do we have? 1/2 y squared. Why do I have 1 over y? Should I have 1 over y? Nope, I should have y. Okay, I'm looking at that going, that doesn't look right. So my 1 over y right here, guys, sorry, that should just be a y, because when I multiplied my y over, it should have been moved to the top. So let me fix that right here. This should be y dy, not 1 over y dy. So the integral of y dy is going to be 1/2 y squared. That looks a lot better. Okay, and then the integral of the right-hand side, I'm going to have my 1/2, and e to the u just becomes e to the u plus c. So that side's not too messy either. When do we want to solve? Now remember, we got initial condition 0, 8, and we want to solve for c at some point. I feel like this would be a good time to plug in our values. So I'm going to take this 0, 8, and I'm going to plug it in to this equation right here. So now we're definitely going to be taking over other space. So this is going to become 1/2, and instead of y squared, I'm going to put 8 squared, and that's going to equal 1/2 e to the, well, and the u's not going to work because I've got to change, instead of a u, what was my u? Negative x squared. So this is going to become negative x squared plus c. Oh, but not x, because we plug in 0. So negative 0 squared. So 8 squared is 64, half of 64 is 32. And then I get 1/2 e to the 0 is 1. So I get 32 minus 1/2, so 31.5 equals c. So now that I know my c value, I can plug it in right here. So let's switch colors again. So 1/2 y squared equals 1/2 e to the negative x squared plus 31.5. Now let's get y by itself. So if I times both sides by 2, y squared equals e to the negative x squared. Now be careful, when I times the right-hand side by 2, I've got to multiply both terms by 2. So multiplying 1/2 by 2 makes it go to 1, but I have to multiply the 31.5 by 2, which is going to be 63. And then we're going to take the square root, so y equals the plus or the minus root of e to the negative x squared plus 63. And I don't think we want both of those. But we do have initial conditions. I know that when I plug in a 0, I want to get an 8. So that's going to help me eliminate the plus or the minus. So if I plug in a 0, e to the 0 is 1, plus 63 is 64, and I get square root of 64 is a positive 8. So that means, I have no idea what I just did. So what that means is I don't want the negative, I want the positive. So y is going to equal the positive root e to the negative x squared plus 63. I know that's going to be my final answer. See, that's the problem. We should have moved to the end of the page. I know that's my final answer because this negative says that if I were to plug in a 0, it would have given me an answer of negative 8. But my initial condition told me it should be a positive 8. So I know I should get the positive answer right there. All right. Okay. Let's give ourselves a little bit of room. I don't want to erase too much of this. But we can get some of this out of our way. Hopefully that'll be enough for us to work with. So number 6, let f and g be functions that are differentiable everywhere. If g is the inverse function of f, and if g of 3 is 8. Okay, so g of 3, so I get 3 comma 8 for g, and f prime of 8 is negative 2/5. Then g prime of 3 is what? So we're looking for g prime. All right, so I know that if I have the point 3, 8, it told me that f and g are inverses. So that means that the point 3, 8 relates to the point 8, 3 from f. And then it tells me f prime of 8, so f prime of 8 is going to give me negative 2/5. So g prime of 3 is going to be that inverse. It's going to be negative 5 over 2. Negative 5 halves. See, we haven't done those in a little while, but that one's not too bad, quick and easy. Number 7, the derivative of arc cosine of 3x. Okay, this is one of those that you should have memorized as far as all the derivatives and antiderivatives that you have memorized. So the derivative of arc cosine, remember, is u prime over the square root of 1 minus u squared. Now, 3x, that's just my u. So the derivative of the arc cosine of 3x is going to be, no, that's not right. It's a cosine, so we should have a negative here, negative u prime. So the derivative of u prime, 3x, the derivative of 3x is going to be 3, but my formula tells me that it should be a negative 3 on top, and on the bottom I should get a square root, and I have a 1 minus u squared. So that's going to be 1 minus 3x squared. So when I simplify this, I get negative 3 over square root 1 minus 9x squared. And that would be your final answer. Okay, number 8. The integral of 1 over root 4 minus x squared. Again, this is one of those that you should have memorized. This one is going to be our arc sine, because remember, arc going backwards and forwards, the derivative of arc sine is 1 over, a squared minus u squared, right? Or u prime over a squared minus u squared. So going the other way, what I'm looking for, a squared, to get a squared, that means that a is going to equal 2. To get u squared, that means that u is going to equal x. And u prime on top is just 1, so I don't have to worry about anything out in front. So my answer here is going to be the arc sine. And remember, it's u over a, so x over 2. And don't forget to add c. Arc sine of x over 2 plus c. Okay, number 9. The integral from 1 to root e of 2x over x squared dx. Looks a little bit messy. The nice thing is if I take the derivative of the bottom, I get the top. So this is just u prime over u. So my u is going to be the x squared. So u prime over u, remember, that's just natural log of u. So my answer is going to be the natural log, x squared. But I'm not going to have a plus c because it gave me my bounds. So I'm actually going to evaluate that from root e down to 1. So when I plug those in, I end up with the natural log of root e squared minus the natural log of 1 squared. Right? We plug those in. Root e squared is just going to... What just happened? Got excited for a minute. Root e squared is just e, so I end up with, this is just natural log of e minus natural log of 1. Natural log of e is 1. Natural log of 1 is 0. So 1 minus 0 is a whopping 1. All right. And I guess technically, no, that looks good to me. Okay. I was going to say we haven't really broken this up between calculator and non-calculator questions. So that would be a good one to know to do by hand, but you could also, that's one that you could double check on your calculator with the Math 9 option. But we're going to be using our calculator a lot later, so we'll try and keep to doing some of these by hand while we can before they get too messy here once we start finding volumes and things. Okay, number 10. The integral of c over ax plus b dx. Wow, okay. I'm not even going to try figuring out what that looks like. So a and b and c, we know that those are all constants. So if we say, let's let u equal ax plus b, then u prime is just going to equal a dx. And if I look at since c is just a constant, that can move out front. So I can rewrite this as c integral. My ax plus b I changed to be u. And, well, this shouldn't be... Yeah, we're okay. Because maybe we should word this, though, du. Du equals a dx, so my constant... now, I don't have a dx, I have dx. So when I rewrite this, I should probably do 1 over a du equals dx, which means I'm also going to have a 1 over a out front, and I'm going to have a du in the back. And then on top, I'm just going to have a 1, because the c is a constant. I moved it out front. So I end up with c over a integral 1 over u du. And 1 over u du, that's easy. That's just natural log. So c over a natural log of u. And we have a constant. I'm not going to use little c. We better use big. We're going to use k because I'm already using c somewhere else in my problem. And then u, just remember to plug back in what u equals. So I'm going to get c over a natural log of ax plus b, and then I've got some constant k. Just so I don't mix up my different c's. If you were writing this, you could have done a few things. You could have said something like c sub 1 and c sub 2. You could have done like a big C and a little c. It's kind of hard for me to keep track of what are big C's and little c's, mostly because of my handwriting. So I'm going to stick with a constant being k because it's just some constant. It doesn't matter what it is. Okay, number 11. The integral of 1 over x squared e raised to the 3 over x dx. Okay. Wow. Let's rewrite that. The integral, let's move the x up. Let's also move the e to the 3 over x. So that's e to the negative 3 over x. And we can rewrite that again as x to the negative 2, e to the negative 3 raised to the negative x. So I took this x and I moved it up as well. And hopefully that makes it look a little bit cleaner. I don't know about you, but that looks like a great big ugly mess. So I'm going to move it down here. I'm taking the integral of x to the negative 2, e to the negative 3 to the negative x dx. Now, I don't know any shortcuts for this one. So let's just try a u substitution, and let's let u equal this whole thing right here. So let's let u equal negative 3 to the negative x, because then du, or not to the negative x, we're doing negative 3 raised to the, I'm writing this goofy. Sorry. It's not to the negative x. It's negative 3 raised to the x to the negative 1. We've got negative 3 times x to the negative 1. Okay. Rewriting all these exponents in exponents. When I move the x up, I'm not moving it up as an exponent of 3. It's next to the 3, but it's raised to a negative 1. Okay. This looks like it might actually get us where we want to go. Because when I take the derivative now, I multiply that negative 1 down, and it becomes positive 3x to the negative 2. And when I look at what I've got to work with, I have an x to the negative 2, right? I've got x to the negative 2 right here. But I don't have a 3. So let's move the 3 to the other side. So let's rewrite this as 1/3 du equals x to the negative 2. And I should have a dx over here. Okay, we like the messy ones. Why not? Let's plug in the u. So 1/3 integral. My x to the negative 2 is gone. My e just becomes e to the u du. Do I feel okay about that? Did it really clean up that nicely? It really cleaned up that nicely. Okay, I can live with that. Because the integral of e to the u is just e to the u. So this becomes 1/3 e to the u plus c. And I know what u is, so I plug that back in. So 1/3 e, and let's make sure we plug in our u right. Negative, lost my pen. Negative 3x to the negative 1. Barf. Plus c. So I'm going to rewrite that. 1/3 e to the negative 3 over x. Plus c. Yeah, that's messy. I don't know which one of those got messier. All right, let's get on to some easier stuff, right? Like bacteria and growth of bacteria, which is something that we all want to be thinking about right now. So number 12 says that a certain type of bacteria increases continuously at a rate proportional to the number present. Okay, so going back to our current chapter, right? We've talked about things increasing at a rate proportional to a number. And we said that whenever you see something like that, that it's increasing proportional to something else, that's going to look something like a constant times, and in this case, let's use the letter B for bacteria. Okay, so my rate of change is my change of bacteria. So let's call it dB, and we're going to be doing this in terms of time, I would assume. So dB dt, my rate of change of bacteria is proportional to the number of bacteria. So my rate of change, dB dt, is proportional to the bacteria. So K times B. Now, another one of those that you hopefully have memorized at this point, we talked about when we went through and we actually solved one of these problems, we came out with something that looked like, kind of like PERT. It kind of looked like the exponential growth that you see in finances. And it looked something like A is equal to some constant times E, and then we raised that to the KT. So this is the formula that when you see something like it's growing, it's increasing at a rate proportional, you're going to end up using this formula. Okay, and the nice thing about this formula is basically we took what we started with. We took this here and we integrated it and we came up with this nice formula on the left. So a couple of things to remember about that formula on the left. A is the amount that we end with. All right. K is some constant that we're going to have to figure out. T is the amount of time. C is just our initial condition. That's what we started with. That's how much we started with. So if I go back to the problem up here, it says if there are 500 present at a given time. So we're going to call that at time 0. There are 500 present and 1,000 present 2 hours later. How many hours from the initial time will it take for the numbers to be 2,500? So we're trying to figure out when is A going to be 2,500. The problem is we don't know what K is. So we need to find K first. So we're going to use what information we do know. I do know that I'm starting with 500, right? And I know that 2 hours later, I end up with 1,000. So I can put 1,000 on the left, my ending amount. I'm starting with 500, and I'm timesing that by e to some k value, and that's 2 hours later, so we're going to put 2 in for time. Now, if this was a finance class, usually that time would be we'd be dealing with time in years. It doesn't matter what our time value is in this case. We can say that the time is 2 hours. That's okay with us because we're working in hours. So what I want to do is solve for K. So I'm going to... Well, before I know that I got to get K down, but before I natural log both sides, I'm going to take this 500 and divide it over here because then I end up with 2 equals E, and I'm going to rewrite this as E to the 2K. Now I'm going to natural log both sides. So the natural log of 2 is equal to 2 times K, which means that K is equal to natural log of 2 divided by 2. And I'm okay leaving it like that. You could plug it in your calculator. You could save it as a value in your calculator. It's going to be an ugly decimal. I'm just going to leave it natural log of 2 over 2. Now that I know what K is, we can solve how long it's going to take to get to 2,500. So I want to end at 2,500, and that is going to equal my starting amount, which is 500, times E to the KT. So I'm going to put natural log of 2 over 2 times T. And now I want to solve for T. So I'm going to divide both sides by 500. So I'm going to end up with 5 equals E to the natural log of 2 over 2 times T. I'm going to natural log both sides. So natural log of 5 equals the natural log of 2 over 2 times T. And to get T alone, I've got to times by 2 and divide by natural log. So I'm going to get 2 natural logs of 5 divided by the natural log of 2, and that's going to equal T. So let's check that value. 2 natural log 5 over natural log of 2. So if it ever gets me there, 2 natural logs of 5 divided by the natural log of 2. And I end up with 4.6438. So 4.644. So this is going to be 4.644. That's how many hours it's going to take for my bacteria to grow to 2,500. Just under 5 hours. We kind of used a lot of space, but I think we can survive. 13 shouldn't be too bad. What's the average value of negative 2t squared minus 3t cubed over the interval from 0 to 2? So this one does require you to have memorized another formula. Let me give us a little bit of room here. And it's up on the wall on a poster. But remember, the average value formula, definitely one that you want to have memorized before you take this test. But it's 1 over b minus a times the integral from a to b of f of x dx. Remember, that was our average value formula. It's one that we told you you're going to need to memorize. So in this case, I'm going from 0 to 2. So there's my a and my b. So when I plug in my values, I get 1 over 2 minus 0, that's just 2, times the integral from 0 to 2. And my function is negative 2t squared minus 3t cubed. And I know it says f of x dx, we're using t, so it's going to be a dt. You've got two options. Plug it in your calculator if it's a calculator question, or do it by hand. We're going to do this one by hand, and we'll probably start using the calculator on the next one because we're getting into volume and area. So I'm going to have this 1/2 out in front, but I need to multiply that by negative 2t squared. I've got to take the integral. So that's going to make this become t cubed. So I've got to multiply by the reciprocal 1/3. So that's going to become negative 2/3 t cubed. And then I'm going to minus, that's going to become a t to the 4th. I've got a t to the 4th, yes. I've got to multiply by 1/4. So that's going to become negative 3/4. And I don't have to worry about c because I've got limits from 0 to 2. All right, now normally I would have to plug in the 2 everywhere. And then I would have to plug in the 0 and subtract all of that. The nice thing is when I plug in the 0 to t, it all becomes 0. So all I really need to worry about is plugging in the 2. So I'm going to get 1/2 times negative 2/3 2 cubed minus 3/4 t to the, or t. I just got done saying we're plugging in 2 to the 4th. And I don't have to minus the 0 because the 0 turns everything else into nothing. So this becomes 1/2 multiplied by 2 cubed is going to be what? 8. So this becomes negative 16/3. And then 2 to the 4th is 16 times negative 3 is negative 48 divided by 4 is negative 12. And when I multiply that 1/2 in, I'm going to end up with negative 8/3. And I'm going to minus 6. And if this was a multiple choice, you would probably, well, if this wasn't multiple choice, you would have stopped clear back here. But if it was multiple choice, they would probably want a common denominator. So they would times the negative 6 by 3/3. So you would get negative 8 minus 18. So you would get negative 26/3 as your answer. Okay, moving on. Number 14. What is the area, finally, what is the area of the region bounded by the lines x equals 0, x equals 3, y equals 0, and the curve y equals e to the x over 4? Okay, so if I sketch a rough graph of this, y e to the x over 4, remember e to the x, it looks just, well, where did my pen go? We're just looking for something like this. And at 0, e to the 0 over 4 is e to the 0, which means it's going to be it's going to start at 1, and it's going to go up like this. All right? X equals 0. Well, that just means x equals 0. That's this line right here. Y equals 0 is this line here. And x equals 3 is going to be over here. So we are looking for the area bounded inside this region. So I'm looking for this area right here. I'm glad it started us with a nice one. It's about time. So I'm integrating, and I'm looking at my x's. I'm going from 0 to 3, and I want my top curve minus my bottom curve. So I want my e to the x over 4 minus my bottom curve, which is just 0. Is that really all it is? Yes, that is all it is. Okay, so we're going to plug that in the calculator, 0 to 3 of e to the x over 4. So we are going to go math 9. We're going from 0 to 3 of e raised to the x over 4 dx. I don't want to graph that. Where am I going? Enter. 4.468, and then a bunch of zeros. So that's going to be approximately 4.468. Now, if you wanted to do this by hand, you would do a u substitution, x over 4, find du, and solve it by hand that way. I'm not going to take the time to do that today. We can do it in class if you really want to, but you're going to have to change your limits, and this feels like more of a calculator question, and at this point, it didn't tell you couldn't use your calculator on the review, so I think we're okay on number 14. Number 15, find the area of the region bounded by the graphs f of x equals x cubed minus 6x, and g of x equals negative 2x. Okay, so again, if I didn't know what these looked like, if I had no idea, you could graph them on your calculator, right? So I can open my calculator, and I'm going to go to y equals, and we are going to say, okay, x cubed and I forgot already. Minus 6x is my first one. And my g of x is negative 2x. Well, that did not do what I wanted it to do. Enter, go down. Negative 2x. All right. So when I graph, that makes sense, right? The blue one looks like my x cubed, and the negative 2x is just, it's got a negative slope of 2, or a slope of negative 2. So my function looks something like this. It's going up 0, and it's going up again, and then my negative 2x is coming through here. Now, what we need to be careful of on this one, other than my line being absolutely awful, is I'm looking for the region bounded by these two graphs, and I've got a region right here, and I have a region right here. Okay, so I've got two regions that I'm looking for. And my top and my bottom curve change depending on which region I'm calculating. So on the AP test, I would assume that a question like this is definitely going to be a calculator question, okay? So I'm looking for a couple of things. I'm looking for my endpoints, right? So on the calculator, to do that, I would just go to my graph. I would go to trace intersections. I would get near one of my intersections, and I would hit enter a couple of times. And it tells me that my intersection is, where is my intersection? Why didn't it work? Second, trace, intersect. We want to go left bound, right bound. So it traces at, or it intersects at negative 2, 4. So this point right here is negative 2. This one's easy, that's 0. I'm guessing that this one, because this is symmetrical, my right endpoint is going to be 2, okay? So you could have found that by hand. Again, you could have said x cubed minus 6x equals negative 2x. You could have solved and found out, let's see, you'd add the 2x, so you get x cubed minus 4x equals 0. Factor it out, x squared minus 4 equals 0. So you end up with x equals 0, x equals negative 2, and x equals positive 2. Again, this is probably a calculator question. Do not waste time doing it by hand when you can do it quicker on a calculator, okay? So I'm doing two integrals. I'm going from negative 2 to 0. My top curve is my x cubed curve. And then I have to minus my bottom curve, which is negative 2x. But then I need to add my second region, which goes from 0 to 2, and that one starts at negative 2x, is my top curve, and I've got to minus my bottom curve, which is negative x cubed. Nope, it's not negative x cubed. Sorry, it's x cubed. X cubed minus 6x dx. This right here, again, this is a calculator question. That right there can go directly into your calculator, all right? If you can also recognize that this is symmetrical, the left and the right are the same regions, you're just getting double. You could have just done one of these two regions and times it by 2. Whatever you put in your calculator, though, make sure you have it written on your paper so that whoever's grading your test knows how you got the answer that you got, okay? So when I plug this into my calculator, I am going to get 8. Whatever version I plug in. If I plug this one in, if I simplify and rewrite it, which might make mistakes, I don't know. Same thing, you're going to end up with 8, as long as you don't make any algebra mistakes along your way. All right, so number 16, find the area of the region bounded by the graphs y equals 2x and y equals 5x minus 2x cubed. Okay, so this is almost the same graph, except that my x cubed is going to be flipped over. So it's going to be going, let's see, if I'm flipped over rather than going up first, I'm going to be going down and then up and then down. Wow, that is so not symmetrical, guys. I'm going down and then up and then down. So that's going to be my x cubed, nope, 5x minus 2x cubed, right? And then my y equals 2x looks like that. So I'm basically doing the same thing as I did before, but this time my regions are kind of flipped over. So going with what we know, we don't know our endpoints. Those are going to be completely different. We know the middle one's 0. So to find my endpoints, I'm going to have to graph these. I'm going to put 5x minus 2x cubed. And then we also just have 2x. So when I graph those, I'm looking for my intersection. So if I go second, calculate intersection, we're going to go left bound, right bound. So it tells me not a nice number. What is that? Negative 1.22474. Negative 1.22474, which means this is going to be positive 1.22474. So I am integrating from negative 1.22474 to 0. My top curve this time is the 2x minus my bottom curve, which is 5x minus 2x cubed dx. But then I have to add my second region, which goes from 0 to 1.22474. This time, my 5x minus 2x cubed is on top, and I'm going to minus the 2x. That's my bottom curve. Again, this is symmetrical. So you could have taken this region here, and you could have written that as 2 times the integral of negative 1.22474 to 0 of, and if we simplified this a little bit, negative 3x plus 2x cubed dx. That would have given you the same answer as well. Either way, you're going to come out with something like 2.25-ish, I think is where you should end up, okay? All right, let's rotate. Let's do some volumes. Find the volume of the solid formed by revolving the region bounded by the graphs y equals x cubed, y equals 1, and x equals 2 about the y-axis. Well, that was nice of you, test. Let's use the y-axis to start. Okay, so since we are revolving around the y-axis, we care about our y values where we intersect, and we want all of our equations to look like x equals something, okay? So when I graph this, we'll be a little bit careful about doing so. We end up with x cubed, which looks something like this. And then we've got y equals 1, which is going to be down here somewhere, right? And then we have x equals 2. Okay, so my y value right here is 1. And I'm going over to where x equals 2. Well, when x equals 2, if I plug that in, 2 cubed is 8. So my y value is going to be up there at 8. So I'm looking for this region right here, but I am going to rotate that about the y-axis, which is way over here. So I have a gap, which means I need big R and little r, okay? So big R is the biggest curve, right? So it goes, big R goes all the way from my x equals 2 all the way down to x equals 0, because I'm looking at these in terms of x, not y. So big R is 2 minus 0, which is just 2. Now little r goes from here to my curve. But my curve was given to me as y equals x cubed. Now I want to change that to be in terms of y. So it becomes x equals what? The cube root of y. So my little r goes from that line, the cube root of y, down to 0. Right? So it just becomes the cube root of y. Okay, that's looking all right to me. So when I rotate this, my integral is going to be pi, and my limits, I'm looking at my y values, not my x values, because I'm rotating about the y-axis. So I am going from 1 to 8. Those are my y values. And then I need big R squared. So 2 squared minus little r squared. So 3 cube root y squared. And then this is going to be in terms of y. Now, on the test, this right here is far enough. You plug that in your calculator. You don't have to simplify it beyond that. And you get something like 29.531 if you round it instead of trunk it. And again, these are probably going to be calculator questions. They don't expect you to do those integrals by hand, all right? And I wouldn't even, I know that you could make this for this negative cube root y squared. You could rewrite that as minus y to the, 2/3. I wouldn't do any of that. Leave it in the simplest, the form that you know is correct before you've made any algebra mistakes. Plug that into the calculator, okay? All right, number 18. Find the volume of the solid generated by revolving the region bounded by the graph of y equals natural log, why not? The x-axis, the line x equals 3, and we are rotating around x equals 3. So again, we want our y values, and we want things in terms of x equals. So my graph, what are we looking like on this one? We've got, well, let's start with natural log of x. Natural log of x looks something like this, okay? And we want x equals 3, which is over here somewhere, okay? And we want the x-axis, so that's nice. That's just down here. And we're going to rotate this around the line x equals 3. We're going to rotate this region around x equals 3. So good news there is no gap, right? I am rotating this region around this line. So the region that I'm rotating is right, it's connected to the region, to my rotational line. So no gap. Which hopefully makes our math a little bit easier, okay? So we need our y values. This one is easy because that y value is 0. But my upper y value, this one right here, how did we get that? That comes from y equals natural log of x. And at that point, our x is 3. So y equals the natural log of 3. So I could say, rather than an ugly decimal, let's just use natural log of 3. So I've got my endpoints. Now I just need my big R and my little r. So big R is this line right here. So it goes from, 3 to 0. So it's just going to be 3. Little r is going from here to this line. Okay. My problem is that line is in terms of x. So that line is y equals natural log of x. I want x by itself, so I'm going to e both sides, and I end up with e to the y equals x. So that's my function written in terms of x. So this line right here is actually e to the y. So when I do my little r, that's my right function. So it's e to the y minus my left endpoint. And are we going all the way to 0? Oh yeah, because it's my y value. I'm going from, yes, so we are going all the way to, little r is going all the way to 0. No, it's not. Why are we looking for little r? Okay. I'm looking at this like we're rotating around the axis. We're not rotating around the axis. We're rotating around this line right here. So all we need is big R, guys. I wish you were here to interrupt me and say, Mr. Reed, we're not looking for little r. All we need is big R. So 3 is my right endpoint. My left one is that line that we just found, right? My left one is e to the y. Now we're back on track. Okay, so pi integral from 0 to natural log of 3. And I am going from 3 to e to the y. Are we okay there? Yep. Squared dy. So again, this is what I want to plug in my calculator. And it's going to come out to be approximately 5.929. Yeah, guys, if there's no gap, remember, we don't need little r. We're looking for something that we don't need to look for. I'm looking at that going, wait a minute, our little r doesn't go to 0. Anyway, catch your own mistake before you record a video and you don't catch it till you wasted a few minutes. Okay, number 19. Find the volume of the solid formed by revolving the region bounded by the graphs. So this one looks a little bit nicer. We've got x squared plus 3, so up 1, 2, 3. And we're going over to y equals 3, which is right here, right? And x equals 2, which is right here. So this is 2, this is 3, this is x squared plus 3. And we're rotating about the line y equals 3. It's about time. So we are rotating this region right here. And we are rotating that around y equals 3, which is our line right here. Okay, so again, there is no gap. Where did my pen go? There is no gap. And this time we are rotating it around a horizontal line, thank goodness. So we want our endpoints as x values. And we want our functions in terms of x, which they already are, thank goodness. Okay, so my left endpoint is going to be 0. So I'm going to integrate from 0 up to my right endpoint, which it told me is 2. And I need my pi in front. And since there's no gap, all I need is big R. So my top function is x squared plus 3. My bottom function is 3. So I get x squared plus 3 minus 3 squared dx, which nicely becomes the integral from 0 to 2 of x squared dx. Nope, x squared squared dx. So you can plug that in the calculator if you want to rewrite it as pi 0 to 2 of x to the 4th dx. You're welcome to do it that way. However you plug it in, you should come out with something like 20.106-ish, somewhere around there. Okay? All right, cross sections. The base of the solid is the region enclosed by a semicircle with a radius of 3, lying flat on the x-axis. Okay, so I have a semicircle. My radius is 3, so I'm going from 3, 3, 3. Now, it didn't tell me if it was above or below. It just told me it's on the x-axis, so I'm going to keep it above, because why make it below? It wants us to use cross sections perpendicular to the y-axis, and it wants them to be squares. So my squares, my cross sections are going this way, left to right. Okay, so what we know, the area of a square is the side of the square squared, right? So that's not too bad of a formula to work with. We are going to need, we already know our endpoints. That's easy because I'm just going from 0 to 3. I'm going from 0 to 3. So what else do I need? I do need my top and my bottom curve. In this case, it's my right curve and my left curve, which come from the same formula, okay? So formula of a circle, guys. x squared plus y squared equals the radius squared. Our radius is 3, so our formula is x squared plus y squared equals 9. I need to solve this. Because I'm going perpendicular to the y-axis, I need to get x by itself. Right? Do I need to get x by itself? I am going, yes, I need x by itself. We're going perpendicular to y. So x squared equals 9 minus y squared. So x equals plus or minus the square root of 9 minus y squared. Now, the right-hand side is going to be my x equals positive root 9 minus y squared. The left-hand side is going to be my x equals the negative root 9 minus y squared. So my top curve and bottom curve come from the same formula, but one of them is the positive version, the other one is the negative version. So be careful of that. So I'm going from 0 to 3. And I need to use my s squared function. So I need the length of my side. Well, the length of my side is my right curve. So root 9 minus y squared minus my left curve. So minus negative root 9 minus y squared. And then that is going to be squared, and we're going to dy it. So when I simplify, I go from 0 to 3. Root 9 minus y squared minus another negative root 9 minus y squared just becomes 2 root 9 minus y squareds. But that is squared dy. So that looks good to me. No more simplifying, and we get something like 72. I think. You end up with something like 72 because you're just going to plug it in your calculator. You are not going to try to do that great big mess by hand, okay? Square everything and then raise it to the negative exponent. We're not going to do that. Okay, number 21. To end off on something that we can breathe. If big F prime of x equals little f of x for all of x, then what is the integral from 3a to 2b of f of x dx? Okay. I know that f of x is this right here. So I can rewrite this and say the integral from 3a to 2b of big F prime of x dx. Well, my fundamental theorem of calculus tells me that that just means when I take the integral of the derivative of f prime, I end up with big F of x, but I'm evaluating it from 2b down to 3a, which becomes big F of 2b minus big F of 3. Wow, guys. All I had to do was write an A. Just a simple 3a. 2b minus big F 2b minus big F of 3a. And we don't know what big F is or what B or A or anything else is, so that's it. That's the problem right there. That's your answer.